OnScreen is part of a response from a request to get authors. We've got two fields, value containing the authors and links containing a self-link, which you can see on screen, but as we've seen in the demos, other links like links to previous and next pages are included as well. The links are part of the resource body, and that begs the question, is this really the correct place to put these links? To be able to answer that, we must look back at content negotiation. What we're actually dealing with are two different representations of the same resource, and we're mixing this up. With content negotiation, we ask through the accept header to get back a JSON representation of the resource. So we ask for media type application JSON. But what's returned is a representation of the author's resource with additional semantics, the links, on top of the JSON representation of the author. So the links shouldn't be part of the resource when we ask for media type application JSON. We've effectively created another media type, which we are wrongly returning when asking for application JSON. The same applies to a single resource, by the way. Adding the links to one author, even without an envelope, is also a different representation, thus a different media type. By doing this, we're breaking the self-descriptive message subconstraint, which states that each message must include enough info to know how to process it. If we return a representation with links with an accept header of application JSON, we are not only returning the wrong representation. The response will have a content type header with value application JSON, which does not match the content of the response. So, the consumer of the API does not know how to interpret the response, judging from the content type. In other words, we also don't tell the consumer how to process it. Or well, that may be putting it a bit too harsh, but we're definitely not as strict as we could be. The consumer knows it's JSON, but it does not know anything about what's going to be in there. The solution is creating a new media type. So how do we do this then? Well, there's a format for this, a vendor-specific media type. You can see an example of that on screen. The top-level type is application. And the first part after that is VND. That's the vendor prefix. It's a reserved principal as to begin the MIME type with. It indicates that this is a content type that is specific to a vendor. That is then followed by a custom identifier of the vendor and possibly additional values. A good example in our case would be vnd.marvin.hetos, as you see on screen. VND plus my company, which happens to be called Marvin, which is based on the Paranoid Android from Douglas Adams' Hitchhiker's Guide to the Galaxy books, followed by HeTOS, stating we want to include those resource links. The last part, plus JSON, tells us how to process the media type in JSON format. If this new media type is requested, the links should be included. These are now part of the resource representation, so they go in the body. The consumer must know about this media type and must know how to process it. If it isn't requested, the links should not be included. Let's see how we can support this with a demo. In this demo, we'll make sure that HeTOS links are only returned when the correct media type is requested. When requesting application JSON, only the JSON representation of the resource should be returned. And when requesting vnd.marvin.hetos plus JSON, the links will be included. We're looking at the getAuthor action on our authors controller. We're currently always returning the HeTOS links. The first thing we need to do is get a hold of the accept header value, because our decision depends on that. To do that, we can accept an additional parameter using the fromHeader attribute. That attribute tells the framework that this parameter should be bound using the request headers. We pass through the name of the header, accept, and we give the parameter a name, media type. The first thing we want to do is check whether a valid media type was inputted. For that we call try parse on media type header value. For this to resolve, we need to import the correct namespace. And be careful here, the correct namespace is microsoft.net.http.headers, not system.net.http.headers. So we check whether the media type from the header can be parsed to an actual media type, and if it can't, we return a bad request. Mind you, an accept header can consist of different media types. So if you want to support that, you'll have to use try parse list instead of try parse. For our purposes, we're going to keep this simple and assume that only one type is inputted. Then we can use this value. Let's scroll down a bit to where we currently return the authors with links. Let's surround this with an if statement. This piece of code should only be executed when the media type parameter equals our custom media type. Otherwise, we simply return an author DTO without the links. Let's give this a try. I've got a request lined up here in Postman to get a single author. Let's try sending a request with accept header application JSON. This gets us back the author without the links. If we don't pass through an accept header, we should also get back that same author representation. Now let's try sending a request with an accept header value of application vnd.marvin.hateOS plus JSON. And we get back a 406 not acceptable. What's going on here? Let's have a look at the console output window. We get a warning here. Apparently, no output formatter was registered that can handle this new media type. We can solve that. Let's open our Startup Helper Extensions class and navigate to the Configure Services method. We already know how we can get access to the collection of output formatters. Important to know is that an output formatter has a supported media types collection. We can add media types like application/vnd.marvin.hateOS plus JSON to the supported media type collection of the output formatter we want to handle this media type. But which formatter is that? We added the Newtonsoft JSON formatters. They handle JSON input and output formatting instead of the built-in JSON formatters, as they are more feature-rich. They are, for example, still required if you want to support JSON patch documents, which our API does. The issue here is that these formatters are added after we can access the MVC options output formatters list. So if you look for a Newtonsoft JSON output formatter on the output formatters collection, it won't be there yet. But no worries, we can work around that. We can configure these MVC options afterwards as well. Let's scroll down a bit until after all of this has been set up. By calling into configure on the services collection and passing through MVC options as the type we want to configure, we can configure it again. So on this config objects output formatters collection, we'll look for the Newtonsoft JSON output formatter. Let's import the Microsoft.ASP.NET Core.MVC.formatters namespace for that. If it exists, we add our custom media type to its supported media types collection. Note that doing so allows this application wide. The other way around exists as well. We can restrict certain actions, controllers, or even the full application to certain media types. We will cover that approach when we reach the produces and consumes attributes later on in this module. Currently, we want to allow including HateOS links in the representation globally for all our resources. Let's give this another try. And let's send the request with our custom media type as accept header value again. And there we go. This time the links are included in the resource representation. Up next would be doing the same as we just did for authors when creating an author and so on. But this follows the same principles as we just learned about, so we're not going to do all of that. Okay, so this is already an improvement, but media types can be much more valuable than this. Let's learn what else is possible. We've just used our first vendor-specific media type, and we immediately noticed the advantage of it. But there's more we can do. These days, more APIs are using vendor-specific media types. Let's use an author as an example. We're currently using the author with concatenated name and age as the return type when getting an author. We assumed that that's the representation most consumers would want. But is that really the case? You could imagine that some consumers might want the author like that, but others might want the author with first name, last name, and date of birth fields. Those are thus two representations of the same author. Yet, we cannot request these when we use application JSON. Our API does not know which representation to return. It just knows that we want something in JSON format. With vendor-specific media types, we can specify the exact type. We could create two vendor-specific media types. One friendly author media type for the friendly format with age and name, and one full author media type for the representation with first name, last name, and date of birth. This tightens the contract between client and server and thus makes our system more reliable and evolvable. These vendor-specific media types are what are called semantic media types. Media types that tell us something about the semantics of the data, i.e. what the data means. A vendor-specific media type can thus be a semantic media type if it is used in the way we just described. But how do we combine that with HateOS links? Application/vnd.marvin.hateOS would give us an auto representation with links. But the other media types wouldn't. We could fix that by creating a new suffix. Plus JSON is a suffix, and we could add a plus HateOS suffix. Like that, by using the media types you see on screen here, consumers can ask for different representations with or without links. This is something you see in the wild from time to time, but there's a little issue with this. According to the media type definition, there should be only one suffix per media type. Next to that, only officially registered suffixes should be used. So while what I put on screen there will work, it does violate a few best practices. In that regard, it is better to add the HateOS part to the type itself, as you see on screen now. Important to know is that we should always return a default as well, by which I mean the representation that should be returned when a user requests application JSON. Let's say that that is our friendly representation without HateOS links. And of course, we also still want to support application/vnd.marvin.hateOS plus JSON. Well, that sounds like quite a bit of work, but it's actually not as much work as it seems. Let's learn how we can implement this